All right, so welcome to the Education Symposium, where we're going to be discussing the second edition of the Exploring Animal Behavior in Laboratory and Field book, which is currently in production. In keeping with the true spirit of the first edition, we solicited submissions from ABS members. We expanded the scope of coverage and recognized the way in which activities are presented. The volume is divided into 4 main sections: describing behavior, theory of behavior, application of behavior, and communicating science. The aim of this symposium is to demonstrate and discuss 6 chapters representing multiple sections of the book. Not only will this provide us with an opportunity to collect feedback on the chapters, but it will also offer a preview of what the volume offers. Chapters provide variations that permit use in labs, standard class periods, or online learning. Each of the 3 sessions pair 2 chapter authors to discuss their chapters. We have selected chapters that do not involve the use of live animals in order to facilitate authors trying out each other's labs.
Today, we're highlighting 2 chapters, one from the Describing Behavior section and one from the Theory of Behavior section. Ayla Roberts will be presenting on behalf of herself and co-authors Olivia Spagnuolo, Darren Incorvea, and Elizabeth Tinsley Johnson, A Question of Behaviors, How to Design, Test, and Use an Ethogram from Describing Behavior. And from Theory of Behavior, we have Eduardo Bessa from the University of Brasilia, whose activity is called Predator Strike and Prey Counterstrike. We're going to start with Ayla. Ayla Roberts teaches in the Department of Integrative Biology at Michigan State University. She spent her doctoral and postdoctoral years studying primate behavior in Ethiopia and Kenya. She developed the original version of this project late in her PhD program at the University of Michigan when she was asked to develop a new course on observational methods. In that course, this project was completed by groups of 3 or 4 students across the entire semester to give them practice in developing, executing, and presenting an observational project. Ayla now includes a shortened version of this project in her online animal behavior course. And so I will first turn it over to Ayla to describe the activity.
Thanks, Sue. So as you said in the introduction there, the overall purpose of the activity is in that title, How to Design, Test, and Use an Ethogram. So students are asked to put themselves in the shoes of a behavioral researcher and one who is starting a research project. So they'll first select a study species and a question, and again, this can be done in a group or individually. For this particular one, I'm going to talk about the individual setup. They will then complete their first learning objective, which is to formulate a testable hypothesis and predictions about animal behavior. Students will then complete 3 objectives focused on the ethogram itself. Each student will construct, test, and revise their ethogram so that it allows them to test their prediction. They will create their ethogram using empirical descriptions, which is the second objective related to the ethogram. And they will differentiate between state and event behaviors, which is, as we know, very important. So then they will swap ethograms, either individuals swapping with a partner or groups swapping between groups, to pilot each other's ethograms. So they'll have their own test of it and then another individual who hasn't seen the ethogram before test their ethogram out. So then there will be revisions of the ethogram at that point, and then students will be able to use their new and improved ethograms to collect behavioral data and test their predictions. This requires completing the last learning objective, which is to select an appropriate behavioral sampling technique to answer their question. So when I run this in my 7-week online course, we run this kind of in a shortened time span. Takes about 3 weeks from beginning to end. But before we start the project, we have students practice using ethograms to collect data, once where we provide an ethogram for them and once where they actually design their own ethogram. So this isn't like their first interaction with an ethogram. Then they complete the steps that I listed above or before, where they go through that setup process and they test their ethogram, and then they complete their project. In the online version, we do very limited data collection, only about 2 hours of data collection to test their ethogram or to test their prediction. So their predictions are really pretty simple in this setup. But the project obviously can be tailored to fit many needs. Like I said, I used to run it so that students would have the entire semester in their group to go through this process. In that case, I would have them collect about 10 hours of data per person across the semester. So if they had a group of 4, they would have 40 hours of data collection. So I think that the strength of this project is that it can be tailored to be as short or as long as you want it to be, and you can include a presentation aspect as well. Even in my online class, I have students make a video, a podcast type presentation, or they can write it up individually what their findings were. And I think that the students really enjoy it because they actually get to go through the entire process and then see the fruit of their labor.
Okay, questions?
Yeah. Do you girls want to start the question session?
Go ahead,
Yeah,
Eduardo.
go for it. Okay. I was wondering one thing while you were speaking. When you do it in groups, how do you deal with interpersonal trust? How much their data differ from one another?
So I have the students set up a group contract at the beginning of the semester, and they come up with ways to communicate with each other and come to an agreement of how they will get over any disagreements they might have. And having them do that contract seems to really set them up to work together, having laid out those rules. And so they normally went out in pairs and did data collection when I had that set up, and they had data checks that they had to come in and show across the semester. I've done this much. You know, students can tell me if they're having problems with different partners or whatever else. But
Nice.
yeah, I think that because they start the project from the beginning, they're very invested in it. So they want to be proud of it at the end. And so they, for some reason, that makes them work harder.
Yeah. Yeah, I was just wondering because sometimes like one person says, well, the animal is moving, and another one, no, I don't consider that moving, and it's difficult to calibrate everyone's eyes.
Yes. So actually in the, when I had groups the first time I was running it, I had them test the ethogram on video together. So they would do inter-observer reliability testing within them.
Yeah, that would do. That would do.
Instead of between groups, but then they don't get quite as much exposure if you keep it within that same species in that same group. So they're, but building into inter-observer reliability is obviously a great expansion if you have that time.
Yeah. I had my wife doing your applying your chapter, so she was the naive observer applying your chapter on some parakeets in our backyard here. And the first thing she really had trouble with was watching the animals itself. She was quite she found it quite nice to experience my profession. So that's what you keep doing. All the weekends you go away, or field trips you go away. She find it kind of fun. But one thing, she's very short-sighted. And even though she had her glasses on, by now we are 4 months into lockdown, and it's a bit like it lost the focus a lot, and she just couldn't watch as perfectly as she wanted the parakeets on, mostly like on trees when they were on fences or something. It was easier for her to spot them. But when they were further away, she found it kind of difficult. Did you ever have a problem with short-sighted students?
I have problems with that, but also with like visual barriers in like a captive setting where the students don't have view to the entire exhibit, and zoo animals have that knowledge of where they cannot be seen and cannot see the people there. So I have that problem, and I tend to just lay it out very openly at the beginning with students and say, you need to try it. You need to test it out. You need to get there, and you need to make sure that you're going to be able to collect the data that you want to collect. And whether there are visual barriers or not, you have to have X number of minutes of the animal in your site. Keep that in mind when you are deciding what you want to do. I've had some students work with wild birds before, and they said, oh, every day I looked out at 10 o'clock and there they were. And then the day that I went to do my data collection, they just weren't there. And, cool, so you're going to do it again tomorrow? You know, this is what you do as a behavioral researcher, right? You're putting yourself in the shoes, and you have to, you know, you're at the mercy of the animals to some extent. And it's frustrating for students. And I think that's one of the most talked about discussion points at the end for, like, what was the challenge? What did you face in the situation that you weren't expecting? They, you know, I wasn't expecting the animal to hide off camera the whole time, or whatever. So that I think it's part of the experience, and I just make sure to put that rule in that they have to have that number of hours with the animals visible, and where they're being able to differentiate the behaviors that they have laid out. In the case of being nearsighted, I think that I have mentioned before, if I'm on campus and I can lend you my binoculars, I will lend you my binoculars, or go and see if you can borrow some from somebody, because that will help, and that will actually put you a little bit more in line with what many behavioral researchers do.
Yeah. This brings me to another question. When she first started having problems seeing the animals, I suggested her, why don't we choose something simpler, like the bees on the flowers, or something you can get closer to? And she was, bees? No, I don't want to watch bees. I wanted to watch like macaws, or some falcons. Sometimes they come around here. And I said, no, but you're not gonna have enough sample if you choose a very complicated animal. And she was kind of frustrated about that too. How do you get your students to choose their subjects, and how much trouble do you have making them choose something simpler, but that they will be able to assemble the data?
Yes, this happens a lot. So I actually have my students lay out a proposal before they do their data. So they might come to me and say, you know, I want to study lions, bears, tigers, whatever. And I'm like, oh, okay. So what is your question going to be? Where are you going to watch them? How are you going to be able to, you know, make sure that they're active enough that you have behavior other than just resting or whatever. And that is often a reality check for them. Oh, I didn't think about that. I had a student who wanted to study manatees this last semester, and she was like, they don't actually do that much. I was like, yeah, that's why you try it out. That's why you got to go and look for the behaviors. So you have to be really very specific if you, you know, want to have something that you can test. I also do require them to have 8 different behaviors. So it can't just be like swimming and resting or something. So I tell them to think very carefully about what species they're going to have, what the habitat is. So often a lot of the people that are interested in carnivores will end up watching a zoo cam or something like that, which is great, especially in a pandemic that we have so many streaming live cams. But they often will find that their animals are curled up in a corner somewhere resting during many of the daylight hours that my students would prefer to be observing their animals. So I bring up alternative species. You know, is there somebody you could go and borrow their horses, you know, in their, you know, back paddock or whatever. Something where they're still able to get the experience. And if they're adamant and they go for the, you know, lazy but charismatic megafauna, then they end up having the challenge of not having enough data to answer their question, and they have to lay that out in their paper or in their presentation, and that doesn't feel good to them. So I always bring that up and say, think about how your findings are going to sound. What's that going to look like? And many of them will try it, even though we've had that conversation, and then change their approach after that. But that again is another part of behavioral research experience. So
yeah, that's learning too.
mm-hmm.
One of the things we experienced here too was that well, first my wife wanted to know why the parakeets hang by one feet and spin around a pole or something we have here. And I said, yeah, that's a very nice question. How would you approach it? And she just could have no idea at all. I think it is like sort of to have fun. I said, yeah, that's a very good hypothesis. How to test it? I don't know. So she gave up on that, and she wanted to know what makes the animals, these parakeets, eat with their beaks in a jar or something, or grab it with their feet and put it in their beaks. So she decided she hypothesized that the size of the seed would define how the animal grabs the food. And we tested with bird seed and sunflower seed, and mostly they picked it with the beak every now and then for both the seeds. And she was like, yeah, but this is not working. I said, what's not working? No, they're not picking the big seeds with their feet. And I said, but that's not working. It's working perfectly. Just your hypothesis wasn't right, but that's all right.
Mm-hmm.
No, I have to get it right. And did you ever experience that with your students? Are they frustrated by not getting, like guessing right the first time?
Yes, absolutely. And I mean, we also run into issues with how much can you say after 2 hours of data collection?
Yeah.
Maybe not as much as you want to be able to say. So yes, and I think this is a really good question. And I think this is a really excellent lesson for students in a behavior class to experience the disappointment in having a hypothesis not supported by your findings. And most students they do go the route of, well, if I had more data, I probably would have been able to say that. And I'm like, well, yeah, okay, you could say that, but instead you could be a little bit more positive and say, alternatively, what could your explanation for this behavior be now? Like, let's think about the scientific process and putting yourself in the shoes. Let's say this was a thousands of hours study and this is still your finding. What would you then say with this knowledge that you have from your study? Where would you go with it? What would your next alternative hypothesis be? You know, and kind of bring them back to the scientific method and say, okay, so not all studies have findings that support the original hypothesis, but now what? What's next? You don't just give up. That's not how science works. So, so I think that it is disappointing for them, but when we lay it out in terms of, okay, it's a minor setback, but now what? They can kind of think a little bit more deeply about it. And I often tell them, whether or not you reject or support your hypothesis is completely irrelevant to this project. We don't care. It's about the journey, you know, not about the destination of the project. And hearing that sometimes stresses them out, but I think also can relieve some of that stress that they feel as a disappointment. Their project is a failure. And I'm like, no, you're still going to get all the credit, which is obviously what a lot of them think about. But that it really gives them a truer experience than if their projects always worked.
Yeah.
Yeah, it sounds like it's a great learning experience for the students, for sure, and a little bit of a reality check too.
Yes.
Yeah. I think we should probably move on now. And so I'm going to ask Heather to introduce Eduardo.
So our second chapter is done by Eduardo Bessa, who is a professor of zoology and a supervisor in the ecology graduate course at the University of Brasilia. His research focuses on fish reproductive behavior and on behavioral impacts of ecotourism. Eduardo has been a member of the ABS Education Committee for 10 years now, and he teaches a course on animal behavior in which students participate in field trips around central Brazil and eat lots of candy. Turn it over to you, Eduardo.
Thank you, Heather. Well, it was a great opportunity for me to write a chapter in this book because I really like lab and field exercises on animal behavior, the first version of the book, the first edition. So I was quite happy to take part of this this time. Well, as much as in Ayla's chapter, she wanted students to put themselves into the shoes of an animal behaviorist, I more or less wanted students to put themselves in the shoes of predators. So this is less an experiment or than a classroom activity or dynamic, just to simulate a sort of behavior that would only seldomly be seen in the wild. So if you really wanted students to go outside and watch an animal prey on someone else, it would spend a lot of time with no records, and probably wouldn't be very productive time. So the idea of simulating it was what drove me to this exercise. And well, first, what we have is our students will be predators trying to capture lollies. So these are the lollies. And I suggested 3 setups. In the first one, the predator has to spot the prey. So you have sort of a jar full with colored buttons like this, and a few lollies inside somewhere that you have to chase and capture, find, and seek and capture. And that more or less makes the students experience how visually oriented animals try to find their prey. Then you have escaping preys, sort of like lollies in a long jar. And you have the chopsticks to pick the lollies with the chopsticks in the jar without using your hands, except by the chopsticks, sure. So these are escaping preys. And then once the predator found the prey and captured the prey, you have to somehow disembowel it or get access to the meat inside the prey. And sometimes here are some lollies, and sometimes they have a shell or sort of a spines or thorns or something that avoid the predators getting to what's really interesting for them. So what you have is like 3 people per group, and these people are going to try each of these one of these methods to get to the prey. And you can just log their how long they took to get the first prey or a few prey, and experience how difficult things are for predators, because once you have like natural history channels, mostly you get like life is really tough for preys, but rarely they explicit how hard life is for predators too. So these dynamics, this exercise really has them in the predator shoes and experience how difficult it is to capture the prey too. So after finishing these representations, they just discuss questions about like what animal would be a good performer of activity one, where they have to find the prey, what animal would be a good prey, represented by the lollies amid the buttons there, so that they can transpose everything they have learned with the activity to the natural world. That's mostly what the activity is about. And as I said, like many students join the course both for hiking around the central Brazil, and many students join the course just for eating lollies.
All right, so we'll move on to questions.
Great. So before I start my questions, I just wanted to kind of lay out for everybody. I ran this as an extra credit assignment in my online course. And because it was extra credit and my students are remote everywhere, I couldn't have them work together in the collaborative way that it was set up, which I was very bummed about. And I think I would like to figure out a way to do it online with everybody involved next time. But the setup that I had was I asked students to do individually on their own, lay out a video where they introduce this idea of predator-prey dynamics, and specifically talking about how hard it is to be a predator. And they were aiming it at an 8th grade audience, or like 13-year-olds, so that they were really breaking it down into simple terms and wouldn't just be able to regurgitate, you know, what we had read in our texts and stuff. So then the students ran each simulation 3 times on their own and collected the data, and then used that data to answer the questions that you had laid out. The overwhelming feedback was the students loved it, and they also did enjoy their candies afterwards. But I did have a couple of questions. So I was wondering, in my students, I felt like they had a pretty good grasp of the predator-prey material at that point. And I'm wondering if you run this at the beginning of talking about predator-prey stuff or at the end, and if maybe you think that there are different costs and benefits to doing it earlier on when they're a little bit more naive about the background material, versus later, and maybe it's different with the group setup.
Yeah, mostly I use it during the beginning of this subject, the predator-prey relationship. So what's good about that? Mostly for me is that sense that when you get to the theory of this subject, they spend the whole theoretical lecture saying, oh, that's more than that. So they really realize much better how things work once they have experienced that. So that's why I usually put it in the beginning of the term, this module. But I have used it in the end too. I just they do realize clearer. It's clearer for them why what are they experiencing. But I think the perception of how things work during the exposition is better if you use it before.
Yeah, that's I thought that would be maybe true, so I'll keep that in mind next time I run it too. My second question is, I gave this to my students as, you know, extra credit, so I just kind of gave them the instructions and waited for them to be submitted. None of them asked me questions. This resulted in them having a little bit of confusion about whether to use their hands or chopsticks for all for the first and the third trials there, or simulations there. And I'm wondering if you have this problem in person, or if it's just easier because you're there and you're watching them.
Yeah, since this is an activity I have been using for quite a long time now, even for explaining it in the textbook, it was quite difficult for me because everything seemed so clear that left many steps out of my explanation, and that gave a lot of trouble to Heather and Sue. But yeah, of course, being by them is much easier to direct. In fact, I once used the chopsticks with the wrapped one inside and with the chopsticks to be grabbed by to one student that got really late to the classroom. So it was sort of a punishment. But generally, no, you use your hands in the first case, you use your hands in the wrapped up case, and the chopsticks only in the second case.
That was my interpretation, and that's what the instructions said, but students still were, you know, they get creative.
No, it's better to make it clear in the chapter, so it's a very good tip too.
Awesome. My last question is that because my students were working by themselves and they weren't able to get that back and forth discussion with others, I kind of cut down the discussion questions, and they were also trying to make like an instructional video for these 8th graders. So I was trying to make it streamline it a little bit to help them get through primarily the first questions that you had there, which I think were the most important. And so I'm wondering how you set up the discussion differently in your in-person class or with the larger group. And if you have students actually record their answers and submit them, or I know you have an answer key in the chapter, which was great. But do you like give that to the students afterwards? Do you think that's helpful? And just kind of maybe lay out that process would be awesome.
So in an in-person version of the activity, I would just like ask the questions, give them a few minutes to think about it, and perhaps write down their answers, and then choose one or two students to comment on, or ask someone else if they wanted to complement it to complete the answer. It wouldn't be necessary for each one of them to answer all of the questions in front of the classroom, the whole classroom. But I was thinking about how to operate it in an online version, and I think you did it really well. Your idea was really good. I never used it online, and it was a good idea how to deal with it. If I had to put it in an online course, I reckon I would use the forum for that, and just like open one topic of the forum for which of the questions, and just leave them talk there, or perhaps like get more shyer students to send closed responses to me, or stimulate them to answer in the forum. But I guess the forum would be the best tool for that in an online setting.
Yeah, that's what I was thinking, and I was regretting not being able to do that because it was extra credit, so I didn't know who was going to be doing it. But I think that that's awesome. That's a great idea. Thank you.
You're welcome.
It seems like a very fun activity to do with your class. Now, we kind of suggested using lentils or buttons instead of candies, but I could see where the candies could be more attractive.
Yeah.
I think we should probably wrap up. So let me just thank Ayla and Eduardo for contributing to the lab manual and for their willingness to participate in this workshop symposium. We hope that everyone will have the opportunity to view all of the chapter presentations that comprise this workshop as well. And we hope that many of you will choose to use the exercises from the new lab manual when it is out next year. So thank you everyone for your time.
Thank you.
Thank you.